Hey, our goal today is to talk about the difference between independent and dependent events. So, let's start with a real basic idea. If I have a standard deck of cards, I might pull a card from the deck. So, let's take a shuffle, and I pull out a card. Two of hearts. Now, I want to talk about the probability of drawing another heart. If I put this card back in the deck, it's effectively the same deck I drew the two of hearts out of, which means the probability of drawing another heart hasn't changed. On the other hand, if I take this two of hearts and I toss it out of the deck, now that has fundamentally changed this deck of cards. Now it only has 51 cards in it, and in that 51 cards, it's no longer going to have the 2. So out of my hearts, I'm now down, instead of 13, I only have 12. So then I'm going to go ahead and I can try and pull another heart out. The probability is going to be less because I've modified how many cards are in this deck, and I've modified the number of favored outcomes. In the case of independent events, the outcome on a given event doesn't change as we proceed down the list of sequential events. In the case of dependent events, it does change. So, another example, if I were to flip a coin, whether or not a coin comes up heads or tails doesn't actually change the potential for heads or tails to come on the next toss. Cards, on the other hand, once they're removed from the deck is modified. That changes the probabilities. If I were to be drawing tokens out of a hat, as I draw tokens out, the number of tokens in the hat changes the probability. Coin tossing would be an example of independent. Doesn't matter what came before, it's still going to come again. Generally speaking, when we talk about gender of children, whether you have a boy or you have a girl, generally speaking, that's an independent event. Dependent are things where it is modified as we proceed. Taking cards out of a deck of cards, for example, is an example of your dependent. Rolling dice, doesn't matter what I roll, I'm still going to have the same possible outcomes. Those are independent events. Whereas drawing buttons out of a bag, dependent. Because once I've removed that button to see what it is, I have fundamentally changed the situation. I've changed the number of buttons I'm drawing. That's an example of dependent events. We're still having a little bit of a hard time. Let me try doing a quick sketch, see if that helps. Alright, so here I have a bag. It has let's color them in, 2 black squares, 2 red circles, and a blue triangle. I can talk about the probability of drawing out a black square. Now let's say I'm successful in my first draw. I want to draw 2 black squares out of my bag. I want to talk about the probability that if I reach in, grab something at random, and pull it out, that I'm going to pull out that black square. Now, if I'm leaving it out of the bag, that creates 2 dependent events, because the probability of drawing a black square depends on what's come before. So let's say I go ahead and I grab onto one of these black squares and I pull it out. Now, instead of having a bag with 5 symbols in it, I have a bag that only has 4. So the probability is changed. It's been modified. Let's put some numbers to this now. Put that square back in the bag. And let's put some numbers as to what we're talking about here. On my first draw, if I'm going to put the things back in the bag, the probability of drawing out a black square is 2 out of 5. Now, if I want to talk about doing it a second time, I've been successful the first time. Let's say the probability I'll do it a second time. This is no longer in the bag. So the probability now of drawing out that black square is only 1 in 4. And that's different. This as a decimal represents 0.4. This as a decimal represents 0.25, or 40% versus 25%. So the probability changed. The probability of drawing out a black square from my bag of symbols depends on what came before. Now, if I were to put that black square back in the bag, and so I was always drawing fresh, these would then be examples of independent events, because the outcome that came before doesn't affect the outcome that came later, because I always reset Part of what makes blackjack a very popular casino game with people who are good at mathematics is that the deck of cards creates a long series of dependent events. They don't reset the deck of cards after every draw. So every time a card comes out of the deck, so they're handed a 6, and they're handed an 8, so a total of 14, these cards are no longer in the deck, which means the probability is now modified. Other casino games, such as craps, roulette, and other ones where it's a large game that everyone bets on, they get reset after every round of betting, creating a long series of independent events because the probabilities all fall back as though every shape are back in the bag, every card were back in the deck. Independent events refer to ones where there's no relationship, we have a reset. Dependent is where my pool, my deck, my bag, is modified by every test along the way. Hopefully this gives you a nice idea then between what an independent versus dependent represents, because the formulas vary based on the two.